Okay.
So thank you so much for agreeing to meet with me, Dr. Hurwitz. Really glad to have this opportunity. If you wouldn't mind telling us a little bit about your background and introducing yourself.
Okay. So I did my undergraduate in biochemistry and molecular biology, and after I finished my undergrad, I found out that I was a really awful bench scientist, and I found a job working on the Human Genome Project, and so I started learning computer science and learning how to code and learning how to manipulate genomic data, and then I spent about 13 years in industry and working in genomics before I finally decided it was time to get my PhD. So I got a PhD in ecology and evolutionary biology, and then went on to become a professor.
Great, thanks.
Yeah.
So given that your work kind of deals with the intersection between the human genome and computer science, if you will, what's the most interesting connection you see between maybe computers and the human genome? I don't know, is that something that you ever think about?
Yeah, so the human genome has 3 billion base pairs. And even though we have sequenced and completed a draft of the human genome, the work isn't really done yet. And so I think using computer science techniques to really mine through all of this genomic data, and especially as we start to resequence different individuals to look at individual variation between people, and to understand what actually is different about us and what makes us human. And then also, a lot of my work really focuses on the microbiome and understanding all of the microbes that live on and in us, and what that interaction is with us as people.
Great, thanks. What made you choose your field?
So it's funny because I started out as being a creative writing major, and I love science fiction, and I love writing, and I started to realize that that as I explored science, I loved all the analytical side of it. And I found computer science, and I found out that computer science is a lot like creative writing, and you're really putting together these different puzzles and telling stories with the data sets, and I found that really fascinating. And so that's how I ended up with this weird intersection between biology and computer science, and then just putting the two together.
Nice, that's great. So what other field do you see as being the most influential in kind of the research being done in your field?
Well, I think there's a lot of work in at the intersection between biology, computer science, and statistics. So there's a really big push for not only being able to mine through the data and understand the biological meaning of the data, but also trying to understand what we can infer statistically and really pull out the important points and value in the data, and that comes from the statistics side. Yes.
So do you see artificial intelligence as possibly helping with that statistical side of things, or is there another way you can see it being applied to your work?
Yeah, so artificial intelligence, I think, is really changing the game in genomics. A lot of times people think of artificial intelligence in terms of like text mining and mining the web and trying to understand and infer these patterns that way, but we can use all of those same techniques in the field of genomics for really using the language of the genome to show us these patterns and show us how different microbial communities are put together or other things and we can use those patterns to understand how the world is organized around us. And we can't see those patterns with our own minds, with our own human brains, and even some of the analytical techniques that we use in bioinformatics take a really long time to do these alignments and find all of this function and annotation. And the machine learning techniques are really helping to guide us to like which data we should really look at. And I think that's the important part.
Definitely. So what do you see in the near or distant future of your field that maybe you're excited about or that you see coming as the next kind of big thing?
One of the things that I'm really excited about is that I think in the world of genomics, we focused for a really long time on disease and on things that are not what is it like to be not healthy? What is cancer? And I think actually what's changing these days with all the incoming sequencing technologies and the capabilities of really looking at the status of our microbiome at any moment, what that gives us is the ability to monitor our health, to understand what it means to be healthy. What does a healthy gut microbiome look like? And by having like all of that information and all of that data over time, we can start to see these early warning signals that we might actually be moving to this like dysbiotic state, or this state of that we might need to consult with a doctor and get some additional input. And so I think really in this new age, what we'll see is like what it means to be healthy. What is the good microbiome? What can we strive for? How can we be our best? I think that's what's coming.
Nice, that's very interesting. And do you think computers will help you kind of determine what those patterns could be that lead to better health? And
absolutely. I think being able to mine through the vast amount of data that we're creating is going to give us that opportunity where all of a sudden we have not only the data sets from these next generation sequencers, but we also have all of the analytics and all of the machine learning capabilities that allow us to derive meaning and understanding from those data sets.
You see, that's interesting because a couple of people I've talked to have mentioned that they agree that machine learning can help find patterns, but that they don't think it can really bring us to any meaningful conclusions on its own, or actually work in the same way that a human mind can work. So do you see those kinds of limitations when you work with the algorithms and programs that you use?
I completely agree. I think that really the machine learning techniques bring us the insights, and they kind of bring the problem space down so that we're able to really focus our search in a way that is faster and more informative. So what I would imagine is in my field, in the world of genomics, what we would do is use machine learning techniques to sort out the noise from the signal, right? To really find what really matters in the data set.
And then you can interpret that.
Then we can take that information and then we can go deeper using all of our techniques that we've used for a long time to understand really the function and meaning of those data sets.
Yeah, definitely. So do you kind of see that as like the ultimate kind of use for the technology, or do you see it going further than that?
I think one of the things that's really interesting with machine learning in particular is the pattern matching capabilities gives us the ability to find things that are novel. So a lot of the work that we do in my lab focuses on finding these novel viruses, and a lot of the viruses we know about, it's very limited. So what you have to do to sequence a virus is first you have to grow its host, and then you have to infect the host and sequence the virus. And only 99% of hosts don't grow. So what that means is you're actually looking at the 1% of hosts that do grow, and then the lucky strike of actually being able to infect them with the virus. So by using these machine learning techniques, we can start to understand all of these brand new viruses just based on their similarity to other viruses that we do have. And we're probably never going to be able to look at except through these similarities and to see those. Yeah.
Nice. Let's see, what else do I have? So switching gears a little bit, in your research, what do you see as the biggest ethical concern that might come up in the research in the near future, or is already coming up in your research?
I think the biggest ethical concern is the use of personal genomic information. Definitely, There are things that we are uncovering that over time we're going to start to uncover more and more information. And so people might, given their knowledge of today, say, oh yeah, sure, I'm fine with sharing my genome, or I'm fine with sharing my my microbiome data sets or whatnot, but then they don't really know what the future entails and what we're going to find.
Or be able to do with that data.
Or be able to do with it, yes. And so, so for example, a lot of people are using, you know, 23andMe and things like that to find their people that are related to them. But now those very same tests are being used to find criminals, you know, based on relatives who have contributed to those data sources. So I don't think people envisioned that when they first contributed their information or data to that data bank. And I think there's going to be many more examples of that. And so I think those are big concerns in my field.
Yeah, no, for sure. And do you see kind of cybersecurity as being an issue in that too?
I absolutely, cybersecurity is definitely going to be a key component. I know for us, you know, even doing research, we go through a lot of, you know, precautions to make sure we protect information. And it's, I think, in the future, people may not know what the meaning of those data sets are. So certainly, like, keeping them secure and making sure that that only the right people have access to them is important.
Definitely.
Yeah.
Another thing that I've always been interested in is kind of the effect of the microbiome on human behavior. So do you look into that at all in your work?
Yeah, you know, that's a fascinating question, and I think it's something that is very much still being uncovered. So there's a lot of work focused now on the gut-brain axis because the microbes that live in our, you know, in our gut really interface with our own human cells, and then those cells then can have all kinds of biological functions that can then trigger different things in our brain and in our mind. And these microbes have evolved all kinds of capabilities that we ourselves as humans have not. So there could certainly be an interaction between our gut microbiome, our health, and our happiness, and our way of being. So I think there's work in that area. My work really focuses more on some of the gut microbiome and its role in cancer and early onset colorectal cancer. But I do have friends in the field that are doing that kind of work, and it's fascinating.
Yeah, definitely. I don't know if this is a question that you sometimes get, because you did mention that you worked with cancer.
Yeah.
There are certain people who believe that that some sorts of kinds of thoughts can help to cure cancer. Do you see any evidence of that from a research standpoint? Because it seems very far-fetched.
From a research standpoint, I think we really don't understand the interactions between, you know, our cognition and way of being and our and certainly our microbiome. But I do know that stress can change the microbiome, and I do know that with stress you can have states of inflammation. And that can then lead to having different microbes that are going to predispose you to cancer. And so certainly we see that within our work, where mice that are stressed certainly can move to this state of inflammation and having a microbiome that promotes that. Yeah. And so I think there is definitely a connection, and I think that it's important to think about that, because there's a lot of things that are tied in our universe that we might not appreciate yet. So
that's very interesting.
Yeah.
I guess that's concerning for all of us slightly stressed out individuals.
Try not to stress.
Yeah. You might get cancer.
We should all move to Hawaii.
Yes, definitely. So you mentioned that you're a sci-fi enthusiast, or at least were a sci-fi enthusiast. Um, Given that now you work with computers and computer science on a professional basis as part of your research, what parallels or distinctions do you see between kind of the sci-fi version of artificial intelligence as perhaps like evil or completely independent and autonomous, and the type of artificial intelligence that you use on a day-to-day basis?
Well, I would have to say the other day when I was searching on Netflix and for my daughter, and they were suggesting all of these words, and I knew automatically, oh, that's an embedding algorithm, and that it's really like helping my day-to-day life. I think certainly my opinion of artificial intelligence and its uses is very different than maybe that sci-fi version from yesteryear. So I think all of us have examples like that where we're seeing artificial intelligence and recommendation algorithms and other things like really having a positive role in helping us to quickly find the things we're looking for, or and I think certainly there's a role for that. There's also some talk about how AI could eventually be detrimental to jobs.
Right.
But the fact is jobs will change and life changes and we will all adapt. There's my evolutionary biology coming in. But there's definitely going to be an adaptation to these new technologies. And there will always be certain jobs, right, that you will never have AI replace the, girls soccer coach, right?
Sure.
There are certainly places that will
not.
never change in nursing and care and places like that that are fundamental to our human, life and position. But I think in a lot of ways AI can help us with some of the more maybe menial tasks or finding patterns and things that we might need to promote our work.
So you definitely see it more of as a tool than as a replacement for human intelligence then?
Yeah, definitely. I see it as a tool. So I think
no, that's
as really, someone who kind of is more grounded in biology, I've always seen computer science and computer science theory as really a tool to benefit, a better understanding of science. And so absolutely I see AI in the same way. Yeah.
Do you ever think that computers will be integrated with our brains?
I think that would be fantastic as I move into the world of Alzheimer's. I'm just kidding. But I think that rather than be embedded in our brain, there's already so many technologies that we use, in aging populations and for individuals that have disabilities or who have had injuries where they need supplemental support. So I can see that certainly being a way to really open the door for a lot of people to help move through something that might stop them from being who they want to be.
Yeah, definitely. That's great. So as someone who works at the university, you interact on a day-to-day basis with students who are interested in your field of work, hopefully. So what do you see as kind of the advantages and disadvantages of our generation as we move into the fields that you work in?
Well, I think that one of the great things about the kind of incoming younger generation is that all of you are much more cyber savvy and really comfortable working with computers. And I think in the future and near future, people will see coding as, on par with English and with math. Right. And your generation will be interacting with APIs and know how to really manipulate data and information on the web in a way that like my generation and older generations certainly have never seen. So I think of your generation as being more of like the, data interaction generation, like those, where you guys will really be the ones to put the pieces together from different fields through all of these portals into data that we're working to develop right now. Yeah.
So do you think that kind of this like amassing of data will really give us that opportunity to find those intersections between fields?
So yes and no. So yes, because I think all of that data is powerful and interesting and can be cross-linked in different ways. But no, because as of right now, we haven't harmonized those data sets, so they're very hard to use for any kind of machine learning type. There's a lot of data cleansing and cleaning and things that have to happen before we can actually use those data sets together.
Yeah, absolutely.
And I think that's happening right now, this sort of wake up for we can't reproduce our science, we need to harmonize our terminologies, we need to be able to talk to each other across fields.
Yeah, absolutely.
And I think once that starts to happen, and we might not be able to recapture a lot of this like legacy data. We might have to really think, going forward. But that's really this next generation is taking the data sets and making them interoperable and making them usable for different groups of people. And moving from this world of science where I grew up, where you are the lone PI in the universe, right? You are the one who's going to like find the cure for cancer and you're going to solve everything. And you're going to move from that world to where, wait a second, there's so much information everywhere. And it's really going to be the hackers that rule the world. That's going to, the hackers will rule the world. Yeah, in my sci-fi version of the future.
No, that's a very interesting idea, like a universal kind of standard for data sets, just to make them more accessible and operable, as you said, interoperable.
Yeah, so we have, in my world, we have the Genome Standard Consortium, GSC, and so we work with them to really standardize and make data sets interoperable and searchable and and reusable. And I think that is really important, but a lot of people don't know how to really do that, and it takes time. And so we're actually, part of what my group works on is actually trying to harmonize the data, trying to make it like all sync up and make it usable. Yeah.
Nice. So. Okay, well, I think that's all the questions I have, actually.
Awesome.
So thank
Great.
you so much for your time.
Yeah, no problem. Yeah, nice to meet you.
Really great.
Yeah, and fascinating questions. So.
Thank you.